Hello, welcome to today's video, which is episode 8 of the inventory tutorial series. In this video, we're going to work on creating a save load system, which you can see here. So I'm going to say walk over these tomatoes and we can get some of these potatoes. In this chest, I'm going to place our 4 tomatoes. In this chest, I'm going to place our 2 potatoes. Actually, I'm going to put 1 potato there and I'll put a potato here. And I'm going to walk away, hit save. You can see here that we've got our save game file. I'm just going to open this. And you can see we've got some collective items, some active items, we've got values. So this is our chest and our inventory. And how that actually looks in game is if we come out and hit play. So those items that I picked up are back. The chest will be empty. If I hit load, the items that we'd already picked up are going to disappear. We can go back over and we can see that our 1 potato is here in the chest, our 4 tomatoes, and our other potato. So if you want to see how I did this, stay tuned and make sure to pay the course fee, which is 1 like or 1 subscribe. And for bonus points, why not hit the bell notification? But with that said, let's just jump into this and see how it all works. Now, as a prerequisite, I guess, for this video, I recommend you watch this save data video I did. I explained the concept kind of behind what we're going to be doing here, so I'm not going to cover over them. I'm just going to go quickly through kind of the code. So I do recommend watching through this video first. That said, obviously, if you are a Patreon, you can download the files and use the code or just follow along as I type the code out. I'm not going to be explaining kind of every little thing I'm doing with the save system because I went into a lot more detail with that here. And of course, you can find that linked in the description below. Okay, so with that said, let's just jump straight into doing it with our little project here. So the first thing we're going to do is I'm going to right click, create, and I'm going to create a folder here. And we're just going to call this save load, and this is where our save load scripts are going to live. So we'll open up that folder there, and then we'll right click, create C# script, and we'll call this save load. Because this is going to be a static class that we use to save and load. Just as a side note, I've upgraded to Rider. I've not been using Visual Studio, so that's why the IDE looks different than the rest of the videos, but the code obviously is all exactly the same. But yeah, just so you know, I'm using Rider now instead of Visual Studio. So we've got our save load script here. And as I said, this is going to be a static class, so we can call it from anywhere. So we can get rid of the start and update, get rid of mono behavior, and we'll just type in static there. So this is a public static class called save load. So the first thing I'm going to do is I'm going to add 2 public static Unity action events, and we're going to call this on save game, and we'll also do a public static Unity action, which is going to take in something that we're going to call save data, and we'll have to make that class in a second. And I'm just going to do on load game for that, and then we're going to want 2 public strings here as well. So public static string, and actually these could be private static string called directory. I'm going to set this equal to save data, and then we're going to have a private static string called file name. And I'm going to set this equal to savegame.sav. Now I'm going to create a public static bool method. So public static bool, and this is just going to be our save, which is going to take in some save data. So this is going to be the data that we want to save to file. And we're going to have a public static load function. And this is going to return our save data. So at this point, I think we need to make this save data. So go back into our scripts and into our save load folder. And I'm just going to, I'll do this within Unity actually. So if we go over here, I'm going to right click, create C# script, and we'll call this save data. So we'll let that compile and open up that in our IDE. So we've got our save data here. So you can see that these have all stopped being read now. So for our save function, I'm going to call the onSaveGame Unity action, just so we know when the game is trying to save. And we can do string dir equals application.persistent data path plus our directory. And here we can say if directory dot exists. So if this directory doesn't exist, and this is using the system.io namespace, so you need to make sure you include that. So if directory doesn't exist, then obviously we need to make this directory, which we can do here by saying directory dot create directory dir. So just very quickly, we've got our string here, which is called directory. This is save data. We're making a dir, another string called dir, which is the application persistent data path, which if you've watched the other video, this is our local low folder on our C drive, plus the directory. So, and we're going to see if this directory exists. So have we saved the game before? Because if we have, this will exist. And if not, let's just create this directory here. So then we're going to make a new string, and we can just call this JSON. And this is equal to our JSON utility dot toJSON data and true. So this data here is the data that we're passing in, and we're going to convert that data to a string, which will then save to file. And this true here is just for pretty print, which I believe puts stuff, it organizes the file a bit easier so you can read it a bit better in a text editor instead of putting it all on one line. And then we can do file.write all text and set this equal to dir plus our file name. And the text that we're writing out is our JSON string. Again, if you don't understand any of this, and this is the last time I'll say this, but just watch the other video I did that I showed at the start of the video and you'll fully understand what I'm doing here. So here I'm going to debug.log, save in game, and then we can just return true. Now, the reason this is a bool is because we may want to return false if some of the parameters don't get met. So for example, if we're already saving, you could check to see whether the file stream's open or if this file's being accessed. But for our basic case, we're just going to always return true if we save. For your game, you may want to do something differently, and then therefore it will return false. So there may be a path that you take that can return false. So the framework's there for you to use if you need to. So for our public static save data load, what we want to do here is we want to get our string, and this is going to be a full path, and this is going to be the application dot the persistent data path plus our directory, and then this time it's plus our file name. So we're going to try and load this savegame.sav file from our directory. And we need to make a new piece of save data just called data, and we'll set this equal to a new save data, which is going to be a new instance of our save data class. And we need to get rid of mono behavior because it's not actually going to live anywhere kind of on an object. We create a new one, and then we need to check now whether our file name exists, like whether the save game actually exists. So we can just say if file.exists, and we're going to pass in the full path. If the file does exist, then we're going to get the file and turn it back into a JSON string. So we can do file.readAllText. So we used write all text here. We're going to do read all text here. And we're going to read all the text from the full path. And then we can use the JSON utility to turn that back into our save data. So we can do JSON utility dot from JSON. And we're going to turn that into a type of save data. And the string that we're going to turn back into some saved data is our JSON. So there we go. And here we can say that on load game dot, and then we can invoke this, passing in the data that we've just loaded. If the file doesn't exist, then we're just going to do else, and we can do debug.log save file does not exist. And then regardless of whether we've, because we've already created some data, we can just return that data at the end. If it's got to this point, it'll just be the new save data that we've made. So for example, if we're starting a new game and the save game hadn't existed, we're just going to return some data to get started with. But if it did exist, then we're going to return our actual instance of the save data. So now let's actually start to build our save data, like what we're going to actually care about saving with our inventory system. And before we can do that, we actually need to serialize a dictionary. So the dictionary is going to be responsible for saving our chest inventory. But you can't serialize dictionaries kind of from the get-go. We're going to need to make our own version of a dictionary that's serializable. So let's just go back into Unity. That needs to recompile. So in our save load folder, I'm going to right click, create C# script. And this one is just going to be called Serializable Dictionary. So in our Serializable Dictionary class, I'm actually just going to copy this in. So this is the code for that. I've got a link in the description, but basically that's this script here. You don't need to know really the ins and outs of how it all works. But back in 2013, there was this question posted about saving out dictionaries and keys. And even though this was the accepted answer, this script here works really well. It says here that you need to derive a non-generic class from that one. I've not needed to do that here. Maybe it's because we're using JSON, but this just works as a serializable dictionary. So head to the link in the description. You can copy that script into our serializable dictionary.cs file. Make sure you've spelt the name of the file right compared to the name of it here. Otherwise, it won't work. So we can go back over to our save data CS file, and we're going to do a public, and this is going to be a serializable dictionary, which is the class we've just made, and it's going to be of type string and a type of chest save data, which isn't something we've made yet. We'll make that in a second, and I'm just going to call this our chest dictionary. And I'm going to make a constructor here and do a public save data constructor. And we can say our chest dictionary is equal to a new serializable dictionary of type string and chest save data. So now we're going to make our chest save data. This is going to be a struct, and we're actually going to put this into our chest inventory.cs file. So here we can come over to our chest inventory script, and outside of this class, I'm going to flag this as system.serializable so we can save it out. And we're going to do a public struct chest save data. And this is going to keep track of our inventory system. So public inventory system, inv system, a public vector 3 of our position, and a public quaternion of our rotation. And then we're going to make a constructor for this. So we'll do a public chest save data. This is going to take in an inventory system, which I'll just underscore inv system. We'll do a vector 3 underscore position and a quaternion, which is rotation. And then we can set our inv system equal to the underscore inv system position to our underscore position, and rotation equal to underscore rotation. So this is our chest save data put together. So now what we need is, so our framework is getting there quite nicely now. So just to have a quick run through. So we've got this action here on load game. That's going to be called when we load the game. And so it's going to get our chest inventory from file. And we can hook into that onload function and check the data and find the chest's inventory within our save data. So let's just go up to the top here. So I'm underneath the iInteractable. I'm just going to do a a protected override void awake. And we may need to make protected virtual void, protected override void awake. We can call base.awake, and here we can hook into the save load dot we can hook into our save load dot onload game, and we can make a new function called load inventory. And we'll create that function here. So this is, sorry, I need to get rid of the brackets. So this is going to take in some save data. And this is going to check the save data for this specific chest's inventory. And if it exists, load it in. So how will our chests that are in the world, so how will this chest here differentiate itself from this chest here? They're going to need some sort of unique identifier that can say like, hey, I'm chest number 1. Does the save data that I've just got from the load game have a chest number 1? And if it does, like, can I get my inventory back, please? And it'll load it into this. This one can be chest number 2. So we're going to need another script called unique ID. If I click our chest here in our test project, you can see I've got all of these chests here. So I've got my small chest here. You can see that I've got this script, unique ID, and I've got a unique ID. This is our ID here. This is persistent between saves and states and scene loads. So we'll right click, create C# script, and we're going to make a unique ID and load this up in our IDE. Okay, so we've got our unique ID script here, and this is going to be a mono behavior because it's going to live on our object. Now we're going to need a couple of attributes above. So we're going to do a system.serializable as well as execute in edit mode. So we're going to have a serialize field, and this is going to be a private string, and we're going to call this ID. And this is going to be equal to a new GUID, and we can do .toString. Now we need this to be read-only, and we need to make our own read-only attribute. So I'm going to go back over to Unity, and I'm going to right-click, create C# script, and we're going to call this read-only attribute. And then we can open this up, and I'm just going to paste this one in. It's a very simple one-line class. It's just public class read-only attribute, and it inherits from property attribute. So now if we go back over to our unique ID, we can add this read-only tag here. And let's just add this to our chest. So I'm going to add our unique ID field to this chest here. And you can see that we've got our ID here. This is our unique ID. So we've got this property attribute, which we've called read-only. It's just this simple script. And this has to interact with a editor script as well. So Back in our project, you need to make a folder called editor, and it has to be called editor. So right click, create folder, editor, spelled like that, like editor. And then here, we're going to create another script called our read only draw. And this is the script for that. So we've got our public override void on GUI, which takes in a rect, position, serialize property, and our GUI content, which is label. And we're just setting the edit for the property to false. So if we go back over to our chest and we add our unique ID script onto our chest, you can see that this ID has been generated, but we can't click in there or change anything about it. And that's perfect. We don't want to be able to change that code because it needs to persist kind of throughout our game. So I'm just going to save our scene there. So that's our unique ID generated. But we're also going to want a serialize field. It's going to be a private static serializable dictionary. And this is going to take in a string as well as a game object. And I'm going to call this our ID database. And we can set this equal to a new serializable dictionary of those types. And I'm going to do a public string ID. And this is going to return our private ID string here. So we can get this ID from other places in the project. And in the onValidate function, I'm just going to want to check whether our ID database already contains a key. If it does already contain our ID, let's generate a new one. And this is just going to make sure that we don't have any keys that are the same. This is going to be a new method called generate that we're going to create. And if it does exist, then we can do else ID database, and then we can add our ID as well as ourselves. So this .game object. So now the actual chest in the world is linked to its ID. So we'll be able to find this, we'll be able to use this information in lots of other places. I also want to make a onDestroy function. So private void onDestroy. And so if we delete the chest from the world and it contains, the database contains this key, then obviously we want to remove our ID from the ID database because it's not a thing anymore. So remove _ID. All generate's going to do is it's just going to do this again. So we can just copy that bit of code there. And once it's generated, we're just going to add it to the database. So this is just covering our backs to make sure no IDs are the same and that the ID database is filled with IDs and the relevant game objects. So that's our unique ID script and our read-only attribute and the read-only draw. So back to our chest inventory script. So we've hooked into this onload game. So now we can actually load the inventory. So what I'm going to say here is if data, so this save data, if the chest dictionary contains our ID, so get component unique ID, and from that component we're going to get the ID, then it's going to pass back out the chest save data, and we can just call this the chest data. So remember, our save data has this chest dictionary, which has got a string. This is going to be our chest's unique ID that we've just generated, and some save data. This save data is this data here. So it's the inventory system, the chest position, and its rotation. So from this chest data, all we need to do then is just this .inventory primary inventory system is equal to the chest data .inventory system. Because remember, our inventory holder, it's got a primary inventory system. So that's the first inventory system that all inventory holders will have. So primary inventory system is equal to the inventory system that's stored in our chest save data. we can say this dot transform dot position is equal to the chest data dot position, and this dot transform dot rotation is equal to the chest data dot rotation. The reason we're saving this is because in your game you may want to be able to craft a chest like in Minecraft and place it down in the world. And if you do that, it's going to know where it was, like what its position and rotation should be. So we're just covering ourselves if we want to do that there. Now, we're not going to do that in this tutorial series. It's not going to focus on crafting necessarily. Maybe that'll come down the line. Let me know in the Let me know in the comments below if you do want a crafting system that builds on top of the inventory system. But if we do get that far, then that's already there for us. We can just read from that. We can spawn in the chest at that position, rotation, and assign its inventory system as well if we need to. As a bit of a route, if you want to go down that on your own, you could have like a chest manager that loads in the data, spawns in a load of chests based on this chest dictionary. So for every entry in here, it will instantiate a new chest and it'll set it to that position and rotation and set its inventory system. So in that way, when you load the game first, there won't be any chests in the world, and they will be spawned in dynamically by like a chest manager based on the save data. But again, explore that on your own, or let me know in the comments below if you want me to do a video on that. Okay, so we're getting close to the end of being able to actually see this all working. I'm going to make a start function on this. So private void start, and we're going to make a instance of some chest save data. So chest save data, and we'll set this equal to new chest save data, which will pass in our primary inventory system. We will pass in our transform.position as well as our transform.rotation. And then we're going to get in touch with our save game manager, which is another script we need to make. And we're going to hook into the data on the save game manager. And we're going to go to the chest dictionary, and we're going to add our unique ID as well as our save data. Now this is a reference, so we've assigned ourselves to this dictionary. As the chest gets updated, this chest dictionary will stay updated. We don't need to do it every time we request to save the game. Now our chest save data is a reference type, so we only need to assign this once, and it's the same kind of, it's pointing to the same place in memory. So we've assigned it to the chest dictionary, which is going to be on our save game manager. So it will always update no matter what we put in the chest. So let's have our save game manager. Let's create that. So right click, create C# script, save game manager. Now you may want this to just be part of your normal game manager. But basically we need like an active piece of save data that everything is passing in its references to. So then when we hit a button to save the game, it can just save this one piece of save data. It's like your save file essentially. It can save that to disk. And we could, in the save game manager, we could have a tick that saves it periodically. So like an autosave function. But for now, we're just going to have a public static save data, because we only want one piece of data to be working with. We don't want to have lots of different save files everywhere. We just want our one bit of save data. So that can be static, which means we can access it like this. We don't need a reference to the save game manager because we can just get this static variable. Now I'm going to do a private void awake. And also, this save game manager class could be static. I want it to live on an object just so I can interact with it a bit more easily in the scene. So I'm going to keep it as a mono behavior, and it'll live kind of like a game manager just on an object in our scene. So the first thing I'm going to do is in our awake function, I'm going to hook into the save load on load game unity action, just like we did in the chest. And I'm going to make a function called load data, and this will be called data. And in our awake function, I'm also going to set our data equal to a new bit of save data. So all that we need to do is when we load the game, we're just going to replace our data with the save data that we've just loaded. So we can do data is equal to underscore data, and I'll make sure I put the underscore there. So this static instance of data is going to be updated to this bit of data here, and we can make this a public static void load data. This is where we're going to be able to save our data as well. So we can make a public static void save data, and here we're going to make a copy of our data, and then I'm going to call our save load class. I'm going to do save, and we'll pass in our save data. And while we're at it, I'm going to make a public void delete data, and we can call save load dot delete save data. And let's make that method over on our save load file. So we've got a public static void delete save data, and all that's going to do is it's going to get the full path as it is up here. And if that exists, then we're going to delete that save file. So that's just an easy way of deleting our save just for testing purposes, or you might want to give the player that option to surface that option to the player. Okay, so let's actually implement this so we can test to make sure it's all working. Okay, so let's actually implement some buttons so we can actually save and load our inventory system. And the way I'm going to do that is I'm going to get our canvas here. I'm just going to right click, create an empty, and call this save load buttons. And I'm just going to add our save game manager to this object. You may want it somewhere different in your scene, but just to make it easier, I'm going to put it here, and I'm just going to put in, let's use Text Mesh Pro buttons, and we'll do save. We'll duplicate that and call this one load, and duplicate that and call it delete. So let's go to our UI and actually sort these buttons out. So we're going to parent them all to the top left of the screen. So we've got our save button, which can go in the top left. We'll bring our load button down, and then below that we'll bring our delete button. And I'm just going to make these bigger just so we can see them a bit better. I'll do the same with the text. I'll just check auto size just to bring them up, and then we can name this button save, load, delete. So our save button, we can do on click, and I'm going to drag in our save game manager, and this is going to be save data. We've got our load button here. Oh, again, on click, save game manager. We need to be able to load the game. Why can't we load the data? Oh yeah, we need a function to actually try to load the data. So let's do public static void try load data, and this is going to call load on our save load system, which if it's successful, it'll fire off this event, and then this will actually do this method here. So let's go back to the game. So under our save game manager, we can now choose try load data. And then for delete, we can do on click, save button, save game manager, delete data. So for ease of trying to navigate to our save game file on disk, I'm going to go over to our save load function, and in our save game, when I hit save game, I'm going to copy the directory to the clipboard. So I'm going to do GUI utility.system copy buffer, and I'm going to set this equal to our directory. So that means that when I hit save, it's just going to copy the persistent directory path to our clipboard so we can quickly get there in Explorer. So let's save our scene, hit play. So we've got a null reference. So what's that? That's because this chest, the big chest, doesn't have a unique ID component on it. So what we'd actually want to do for our chest inventory is put in a require component of type unique ID. Type of unique ID. So when we call get component, that's not going to throw that error. We may also want to cache our unique ID instead of calling get component, but I'll just leave it like that for now. Let's just make sure it's working first. So let's hit play. So let's go over some objects, come over here, press E, pick up our tomatoes, put them in that chest. We'll go get some potatoes, pick them up, put them in this chest. Let's close out of that, hit save. So we can stop playing. Let's come over to Explorer. I'm just going to paste in the directory. So tutorial, we've got our save game.sav. We can open this up in any text editor. I'm just going to use Notepad. And we can see here that our chest dictionary, it had two chests. It had BFE 041A and OCC EC68A. 8E, and you can see that that corresponds with our chests here. So BFEA 041A, OCC EC68E. So that's our save game working. It's got our chest dictionary, it's saved our keys, it's got the value, so it's got item data, instance ID 2432, so that's referring to our tomatoes, and a stack size of 4. So that's all working. If we go back over to our chests and press E, you'll see that there's nothing in them. So we'll close that, we'll hit load, go back to our chest, and there's our 4 tomatoes. Now obviously there's a bit of a problem here that we loaded the game after we'd already picked up these tomatoes off the ground. So to solve that issue, what we can do is in our save data, we can make a list of items, and this is all of the items that we've picked up in the game. So we can do a public list of string type, and we'll call this collected items. And we can do here, collected items is equal to a new list of type string. We're going to need the unique ID on our items as well. So we can do require component, get type of unique ID. Sorry, that's not on our save data. That needs to go on our item pickup script. So require component type of sphere collider, require component type of unique ID. And just like the chest inventory, we're going to want to make a some item pickup save data. So system.serializable, and this is going to be a public struct of type item pick up save data. So again, this is there for if we want to implement, we've dropped an item on the ground and we want to save that position and rotation. We can do that by spawning in new items. We won't use that again in this script, but I'm doing it for you so it's there if you do want to use it. So let's do public inventory item data, and this is going to be our item data. We'll do public vector 3, and this is going to be our position. Public quaternion, our rotation, and we'll do a public item pickup save data constructor, which is going to take in some inventory item data called data vector 3 position quaternion rotation. And we'll do item data is equal to data position position is equal to position, rotation equal to rotation. Okay, so we've got our save data there. And again, just like on the chest, on the save data for the chest, we need to hook into our save load onload game. So in our onAwake function, just above the colliders, I'm going to do save load dot onload game, and we're going to do load game. So here I'm going to do a private string ID, and we will cache our ID here because it is good practice. And I'm also going to do a serialize field private item pickup save data, just called item save data. So we can say our ID is equal to get component unique ID dot ID. And we can do item save data is equal to some new save data, which is going to take in our inventory item data. So item data, our position, just like the chest, and our rotation, just like the chest. And just like we had a start function here for our chest inventory that adds itself to the save game manager's data, we can do the same thing here. So we'll do void start, and we can do save data, save game manager dot data dot, and then we're going to make a list of our active items, which takes in our ID and our item save data. Go back to the save game manager. So we'll go back to our save data, and I'm going to make a public serializable dictionary of type string and item pickup save data called active items, and we'll do active items is equal to this. So when we make some save data, that dictionary is valid and active. In our load game function, we just want to see if this item has already been picked up, and we'll know that if it's contained within our collected items list. When we pick up an object, it's going to add itself to this collected items list, and then when we save our game, we'll keep track of the items that we've collected. So here we just want to say if data from our load game dot collected items dot contains our ID, then we just want to destroy this dot game object. And in our onDestroy method, so if we do get destroyed by getting picked up, we just want to remove ourselves from our active list. So save game manager dot data dot active items dot contains key ID, save game manager dot data dot active items dot remove our ID. So when we're picked up, we're going to be destroyed, and we're going to take ourselves out of the active list, and then we want to unsubscribe from the save load dot onload game action. We don't need to care about that anymore, so we can just unsubscribe from that there. And in our onTrigger enter, before we are destroyed, we can do save game manager dot data dot collected items dot add ID. So we can, when we get picked up, this is where we will add ourselves to the save game manager. So let's just see that in action. So let's go back, hit play, creating missing unique ID. Let's just check that so that's on there now. So all of our items have a unique ID. So let's hit play. So we're going to go over, we're going to pick up these items and place them, these 4 tomatoes, in the chest. And we're going to walk away, hit save, come out of that, go back in. Now here we're going to manually load. In your game, when you start the game, when a player starts the game, you probably want to load then. So like when the application first starts, you'd call the load function, or you'd be in a main menu and you'd choose a load game. You wouldn't just spawn into the world and then load. But here we're going to have to manually press the load button. And you can see that those items have been deleted because they've got picked up. And we'd previously put them in the chest, so they're here in the chest. And we can take them back out, put them back in. So that's the basics of the save loading done. Player's hotbar doesn't currently save, so if I hit save, come back out, hit play, hit load, it's not working on our player's inventory bar. That'll come in the next video. If you want to see that, make sure you hit the subscribe button, hit the like button if you liked this video. As always, the project files for this video, plus early access to these videos, are on my Patreon, which is patreon.com/dampos. If you'd like anything kind of explaining in a bit more detail, I felt like I went quite quick because there was a lot to cover and I wanted to get this video out and to people because it's been a while since the last video. If you need anything explaining, let me know in the comments or head over to the Discord server, which is linked in the description. I'll be more than happy to help you and kind of debug your code with you. Thanks for watching, and I'll see you in the next one. Bye!